Now, this section we can looked at transport layer. So this is our layer 4 from OSI layer. Transport layer, we have transmission control protocol, which is TCP. And part of the TCP, we have TCP header, multiplexing, connection establishment, connection terminations. These are the topics we get looked at. Connection-oriented versus connection-less protocol, user datagram protocol, which is UDP, and TCP/IP applications. These are the things we have part of this transport layer. Now, in our TCP provides error recovery. TCP performs only the functions necessary to deliver the data between applications. In addition, TCP function supports multiplexing, error recovery, flow control, connection establishment and terminations, WADA data transfer and data segmentations. All these functionalities provided by TCP. Now, let's say we have one of the server in here, and we have one of the PC in here. And this PC would like to establish the connectivity with the servers. So PC, at first, it will send a sync message to the server, and servers will reply back. And after that, PC will again acknowledge that one. This is called a three-way handshake. With this three-way handshake, a PC can connect with the servers. Now, from PC side, what we need? PC side, we must have to have IP address. Let's say this kind of IP address. We need to have some port number, and also we need to have protocol. And destination side, they also need to have similar sort of things, need to have some kind of public IP. Then some port number, and also protocol. So in here, a part of the multiplexing, this is logically, we call it socket. It's kind of like a logical socket. Both source and destinations, we need to have this socket. Now, once we have that, after that, PC will send a sync message, and servers will reply back with sync plus acknowledgement message, and then again PC will do acknowledgement. This is called three-way handshake. With a three-way handshake, servers communicate with the PC, or PC communicate with the servers. Oh, this is three-way. Three-way handshake. Now, all these things performed by this TCP. So you have these two protocols, TCP and UDP. TCP is connection-oriented protocol. On the other hand, UDP is connection-less protocol. That means UDP doesn't do any handshake like TCP. So that's why we call it connection-less protocol. TCP provide all other functionalities. Let's say TCP ensure that all the bits will go to destinations. So it will do all the, any issues happen, it will do data reordering, and it's maintain the flow. It does the flow control. If it is data overflow, then it can control those things, and after that, it will segment those data and send each of the segment to servers. But on the other hand, EDP doesn't do any of these things. EDP main job is to send all the bits to destinations, because EDP we are using, let's say, real-time applications. We are using these steps. And TCP we're using for, let's say, data, documentations, those kind of scenarios we are using TCP. So TCP, EDP, we are using those kind of scenarios. Now let's have a look bit more details. So TCP using all these functions, TCP providing all these functionalities such as multiplexing, error recovery, any issues happened when it does the transmissions during that time, any bits missing or not in order, so it does fix that issues. Flow control with the window size it doing, connection establishment and terminations it doing, what are data transfer and data segmentations is doing with this protocol. Now all these things it does with this header. TCP header is a 4 bytes, and these 4 bytes contain header plus application data. That is called segment. So TCP and data is in here, and inside the TCP we have port number, source port, destinations port, we have sequence number, acknowledgement number, and inside there are some other small features we have. With these 4 bytes of informations, TCP provide all these functionalities. Now, another concept we have in here called multiplexing. Multiplexing relies on a concept called a socket. Socket equal to IP address plus TCP UDP plus port number. So when these two devices they are communicating, in both sides we need IP address, protocol, and port number. Both devices that we need this information, and this is called logical socket. Multiplexing using the port number. So any communications we do, we need.
Zahid, is that the same, the VLAN? We call it VLAN somewhere?
No, VLAN is another concept.
Okay.
That's related more on with switches.
Okay.
This is mostly, let's say when you open one website, when you access any internet connections, during that time in the back end, this TCP actually help us to do this connectivity.
Okay.
Let's say multiplexing using the port number. So that means we need source and destinations. We need IP address, protocol, and port number. Source and destinations, we need these same informations. Now, port numbers is one of the important thing we have in our networking areas. Port numbers, they are 16-bit numbers. Well-known port numbers, we have 1 to 1023, and dynamic port numbers, we have 10242, 65,534. So altogether, we have 65,535 port numbers available. So that came up 2 to the power 16. So that many of port numbers we have. So 2 to the power 16 equal to 65,535. And well-known port numbers means some of the well-known applications, they have fixed number, fixed port number. And dynamic port numbers means they're kind of like a random numbers. Anyone can have this, like from your PC, you will get any of the random dynamic port number. The well-known port number, some of the well-known port number informations we have in here. Let's say this is FTP data using port number 20, FTP control using 21, SSH using 22, Telnet 23, SMTP 25, DNS 53. And you can see all these services, they're using TCP protocol. DNS using both UDP and TCP protocol. But DHCP, TFTP, they're using the UDP protocol. DHCP using this port number 67, 68, TFTP using 69, HTTP using port number 80, POP3 110, SNMP 161, SSL 443. So these are the protocol we have, and these are the port numbers we have. These are the common port numbers we have. We need to remember the port number for the exam. And TCP connection establishment. So TCP does this three-way handshake. So it will send a sync message to destination servers, and destination servers will reply back with sync and ACK with destination's port number. And web servers will acknowledge that one. Destination's port number and source port number is 102427. Connection termination. So TCP established the connectivity. Also, TCP terminate the connections. How it is terminating? Terminating with the fin and ACK flag bits are used. So acknowledgement and finish. So it's ACK and fin. It will send to this PC. This PC will send ACK message, and then ACK and fin message again. And then this PC will ACK that one. So it's kind of like a acknowledge, finalize, acknowledge, finalize. So when they do that kind of stuff, then these connections will be terminated. So TCP established the connectivity. After that, it sends the, or it's communicate. After that, it start to do the communications like send or receive data. And also TCP terminate the connectivity as well. So TCP, we call it connection-oriented protocol, and UDP, we call it connectionless protocol. So both of them, they are important in our network. Let's say UDP protocol. UDP stands for User Diagram Protocol. UDP is connectionless protocol. It does not provide reliability, traffic control, reordering of received data. It provides data transfer and multiplexing using port numbers. Applications, we have web real-time applications. They're using this UDP protocol. And UDP protocol, we have source port and destinations port, length and checksum. All these things will be part of our UDP protocol. And you can see that UDP also using 4 bytes similar to TCP, but it's only deal with the port number. It doesn't have other functionalities or features. Open any web page and say abc.com.au. So actually, we can see the web page now. So this page is basically, as soon as you type the web address and hit enter, it's from your PC to that web servers, it established the three-way handshake. It happened very fast, and TCP is actually in the backend, it established the connectivity, and in this way now we are connected with this web server. So any communications we do, every time we open some web servers in the backend, this TCP actually works. And we know that source and destinations, IP, protocol, port number, they are automatically is working. Now, if you'd like to see a bit more details, we can go to our command prompt. In the command prompt, if we do, let's say, netstat, network status, netstat. If we do netstat, see, it will show us active connections. And active connections, we can see the protocol, TCP protocol we are using, and then we have a local address. Local address indicating 127.0.0.1. This is like a loopback address. This is a local address. And this is the port number. And then we have a destinations address and destinations port number. And then at the end, you can see connection established. So there are many web pages, many applications is running. That's why you can see how many active connections I have opened in my computers. And you can see this is the local IP, all the local IP and local port and destinations IP or their name and destinations port. HTTPS, IMAPs, there are many different port number or protocol is there, and this is the IP address, and you can see connection establishment, some connection is closing as well. So protocol, IP, port, and then IP, protocol, and port number. So both source and destinations will have this system.
So does it mean when at home we are having like 10 mobile and computer connected to our wireless router, that means port IP address is the same but with different port number for each device? Is that in that way?
No, you can do it in your own computers. Let's type this command in your own computers, netstat, and you can see that from your computers, you can, from your computers, how many active connections you have, you can see those stuff. This is from my computer only. But if you logged into the router, probably from the router, you'll be able to see all other connectivity. But this is from my PC. From my PC, I can see all this active connectivity. So that means from my PC, I'm using many websites or web page, many applications I'm running. Some application may be cloud-based, some application may be local, but TCP protocol need to be there. Source IP and source port number will be automatically there. For all individual communication, individual sites, we need separate port number. And then we have destinations, and we can see the connection establishment.